So again, thanks everyone so much for taking the time to join today's webinar. My name's Meg, and I head up data and content here at Esri Ireland. And over the past, I suppose, or so now, we've gotten to know and work with a lot of our different data partners across the world who provide both local and global data sets to help a lot of our customers. So very excited to kick off today's webinar with two of those such partners. So quick agenda for the webinar today. We're going to be taking a look at different types of transportation data that can be analyzed and used in your analysis in ArcGIS and ArcGIS Online from two of our different data partners, TravelTime and TomTom. Time to provide some overviews and demos of what their data and platforms look like. So I will let them introduce themselves in just a bit, but for a quick intro, we have Chris, who heads up customer success at TravelTime, and Jaren, who heads up customer program management at TomTom. Just a few kind of housekeeping things before we jump in and get started. Would ask that everyone just remains with their microphone on mute to improve sound quality across the board. Also, if anyone has any questions at any point in time during the webinar, please feel free on the little question panel you should have probably on the right of your screen to go ahead and type those in. We're hoping to have time to follow up with some questions at the end of the webinar, but in the event we do run out of time, we will follow up via email and be in touch. All right, so just a very quick overview of Esri. I think most people on this webinar are probably familiar with Esri and ArcGIS and might even be some current customers here at Esri Ireland. But if not, we provide the world's most robust GIS, or geographic information system, that can be used across various sectors. But today we're going to focus specifically on how ArcGIS tools mixed with additional kind of quality data sets can improve analysis for transportation. So for anyone who might not be as familiar with Esri, we are a software company who offers solutions for mapping and analysis across various different industries, just to name a few on the slide here, but certainly not an exhaustive list. All right. So we do provide a variety of different solutions and tools for transportation data analysis right within the platform. A few kind of listed on the slide here, for example, catchment areas, network analysis, route optimization, and again, not an exhaustive list here either. But combining the data that TravelTime and TomTom both provide with kind of the ArcGIS spatial analysis tools can really deepen that analysis with greater insights. So without any further ado, we will not listen to me speak anymore, and I will hand the mic over to Darren, who's going to share a bit more about the traffic data that TomTom provided.
All right, thank you very much, Meg. So my name is Jeroen Brouwer. I'm working for TomTom as the manager of customer program management. And what that actually means is that I'm working with all the great traffic data tools that TomTom has. And in this webinar, I will explain a little bit more about what kind of data TomTom is collecting. But I will also give you some demos, some Ireland-based demos, so you can really get a grasp of what is possible and how you can use it in the tooling of Esri. Just quickly before I move towards that topic, quickly introduction of TomTom, because you might remember TomTom from the days that TomTom was still a consumer company creating personal navigation devices. But over time, TomTom really changed from a business to consumer company to a business to business company. We're nowadays an independent location technology specialist. What it actually means is that we create digital maps and real-time and historical traffic data for navigation, for analytics, for traffic management, and whatsoever. So TomTom really changed. We're still creating the sat-nav devices. Actually, they're a great source of data, but TomTom is much bigger than just that. And Meg, if you move to the next slide. There you see our kind of mission statement, what we stand for today. Yeah, thank you very much. So TomTom stands for a safe, connected, autonomous world free of congestion and emissions. And in this webinar, we actually deal with a few of these topics as well, specifically around congestion, emission calculations, but also safety analysis. Historical traffic data can be a great source of data. If you go to the next slide, Meg, then I can explain quickly what kind of data TomTom is collecting. Okay, go to the next slide. Yeah, perfect. So what TomTom is doing nowadays is collecting data from a tremendous volume of different devices. This can be TomTom apps, TomTom devices, but actually the majority of our data comes from built-in systems, built in the dashboard of the vehicle, obviously, or from smartphone apps that are powered by our digital maps or traffic information. At the bottom, you see a few of the brands that we're working together with, but the list is much longer than that. Think about Uber using our maps and traffic data for their backend service and the driver apps, but also think about Daimler, for example, using the traffic data in the dashboard. What you see on the top is pretty cool. You see Amsterdam and the road network of Amsterdam, but actually it's just a black sheet where we plotted all of the data we have on it. And actually the way this technology works is that every second your GPS location will be stored and it will anonymously be shared, so we can create the digital maps, traffic data and traffic analytics with it. So in total, you have a huge database of GPS points. And actually, this is a great map of where you can see where people are mostly driving. The more yellow the road, the more measurements we have. And if you go to the next slide, Meg, then I can explain that we create two different types of services that are relevant today. Oh, sorry, going too fast. Right. So for transport planning and modeling, there are a few things that are typical use cases, and you can use proper traffic data as a source. One is, of course, as on the left, understanding current levels of congestion, bottlenecks, where you want to improve. This is mostly based on real-time traffic data. So where is congestion right now? It's also being used to forecast the future. There are all kinds of traffic models that are using historical traffic data based on how people drove yesterday and last week to predict what's going to happen in the future after changes are happening. We have tooling to influence real-time traffic. So think about during construction and you want to close a road because of construction. We got the tooling to make sure people are routed around it. And well, also big use case is assessing the impact. So before and after. This tunnel is constructed recently in the area where I live in the Netherlands. And it's a great tool to measure what's the impact, not just on this location, but for the whole city on how traffic behavior is changing because of such infrastructural change. Well, to go back, and then I go into the demos. If you go to the next slide, you can see we deliver two different traffic related services. One is around real-time traffic data, which is either traffic congestion or speeds in the network. This is typically used by navigation devices and traffic management centers. But the thing we really want to talk about today is the fact that we store all of that historical data in one huge historical archive, which you can query yourself using the Move portal. So we made a self-serve portal where everyone can sign in and make requests on that database. And if you can allow me to share my screen, Mac, then I can start with the demo.
Should be good to go.
There we go. Can you confirm you see the right screen with the Move portal, Mac?
Yep.
Yeah, okay, good. So Move portal, it's a user interface or an API, depends what you like to use. And there are some different products in that user interface. The products we will talk about today is origin destination analysis and traffic stats. There are also other products like road event reporter, where road authorities can actually report roads that are closed, route monitoring, where you're looking at real-time traffic data. That's subject for another webinar. We're focusing on these two tools today. And maybe quickly before I dive into this, why are we discussing this in an Esri webinar? Well, Esri is our partner. They use the system for all kinds of projects, but they're also able to resell access to this. And that's why we're teaming up. And great catch, you can also use all of the output from these services in the Esri tooling. But I get back to that in a second. So let me show you one example of traffic stats. What I did here was I made a query of the Dublin Ring Road. And I just made this analysis so I can check how does the travel look like on that specific road. Well, before I show you the output, quickly how I defined it, it's actually quite straightforward. So first of all, you set up the route or you set up an area. Come back to that. So in this case, I set up two locations, one south of Dublin and one close to Dublin Airport. So I'm interested in this route going north. I selected one date range. So in this case, I selected January 2020 for all of the weekdays, but you can really make any combination there. You can select the whole year, you can select all of the Mondays, and typical use case nowadays is measure a representative week or month before COVID and during COVID to understand what's the impact of people working from home, etc. In this case, the analysis is for before COVID, because during COVID, there's not much congestion to report on. So it makes it a little bit more difficult to explain. So we have the route, we have the dates. You can add multiple dates if you want, and you can define different time buckets, as I call it. In this case, I split up the whole day in 24-hour time buckets. What it means is that we get statistics for each hour of the day. And in this case, January 2020. Well, let's look at what comes out of that. So what you see here is all of the statistics. You see the nice colors, but maybe this is a good way to start. So what we're looking in here right now is for every hour of the day for the entire route, which is around 40 kilometers long, you can see what speed cars are driving. Green means, let me scroll up a little bit. Green means around 100 to 120 kilometers an hour. Yellow and orange really means congestion. So when I scroll down, you can see that on this specific route going northbound, there is some problems in morning rush hour on some different locations, but not really dense congestion. But actually in the afternoon rush hour going north, there is really some congestion happening, specifically between 4 and 5, it's problematic. You can see all of the red colors here. And if we scroll up, it's a little bit slow here. Here we can see specifically between 4 and 5 o'clock. How does the speed look like? We can see there are some congested segments here. And you can really zoom in and understand what's the problematic point. This makes it different than using other technology like Bluetooth or putting even cameras on there, which gives you really valuable information for a longer stretch, while this actually gives you really detailed information per road segment. And you can even click on each segment to understand what's the sample size, so how many cars did we observe, so in this case 5,500, and you get all kinds of statistics around the travel time on that segment and the speed. And I did not mention, but here we can also see the length of the segment. It's a really short segment, only 24 meters long. What's also interesting is that you're not only getting the average, but you also get all the percentiles. And the percentiles explain you something about how stable the travel time is. So what we see here, specifically between 4 and 5, you can see the dark line is the average speed, but you can see in gray everything between the 15th and the 85th percentile. So you can see on the end of the stretch, things are relatively stable. But here in the middle, it's a relatively unstable situation there. Sometimes cars drive pretty fast between 4 and 5, and sometimes cars drive really slow. Typical use case is to use this to identify bottlenecks and then to check after changes in the road network to check what's the speed then and to assess whether the impact is as expected. But also other use cases to assess the safety of the street based on the speeds and what have you. Many different use cases. And important to mention, you can also download all of these results, for example, in JSON, JSON shapefile, but also Excel, so you can really dig into the details and assess it without a need for this specific user interface. Well, in this case, I selected a route, but you can also do the same analysis for an entire area. So I prepared this query for Limerick in the west of Ireland. It's pretty much the same. Also here, I selected January, but in this case, January 21. I again selected every hour of the day, so you can really see the speeds per hour of the day. And what you really receive, typical use case for traffic modeling, for example, or the logistical planning, per road elements, per direction, you receive all of the details. In this case, you see only a few of the details in the user interface. So to take this example, it's a 60-meter road segment. The number of hits is around 400. We see the average and the median travel time, and we see the average speed calculated in two different ways, harmonic and arithmetic. So you can choose which value you like, and the percentiles. Bear in mind, this is just subset you get for all of every fifth percentile you receive the information. If you download the results, again, you can download it in JSON, GeoJSON, or shapefile, so you can load it into ArcGIS to do a further assessment, merge it with other tools, etc. To really get a feeling about what's happening there. Well, maybe good to know, this database is pretty big. You can go back in time about 10 years, and we constantly add new data. And normally it takes around 24 hours. Then you can already query the data from the day before yesterday. So it's really flexible if you want to use it. Well, so this is traffic stats. The quick summary, historical data for a specific route or for an area, and you receive the information per road element, or in case of a route, also for the entire route. So you can really measure the stability of travel times on the route. The other product we wanted to discuss is origin destination. It's a different tool, different purpose. In this case, I made a very simple example for Dublin city center. I selected some of the administrative areas in Dublin. And what we're doing here is we're using that big historical traffic database in order to understand where do trips start and where do they end. You can use this tool in two different ways. One is what I call zone to zone. What zone did the trip start and what zone did the trip end, really beginning to end. I also have one example where you can see that you're not interested where the trip starts or ends. You just want to know for a small area how people travel there. Kind of a replacement for NPR cameras understanding how people travel. Let me first show you this one. So it's quite simple, administrative areas. I think I selected January 2021 for this. Now I selected February 2021. Mostly used is this very simple sheet. It's just a matrix. Where do trips start? Where do they end? So for example, from Arbor Hill to Kremlin, over the duration here between 4 and 8, there were about 950 different trips. Typical use case, all kind of demand models where you really want to understand how is the road network being used. What's also funny, I say funny, is that we also have lots of really short trips. So these trips start and end in the same zone. And well, I discussed it yesterday while preparing, but there are some really interesting things like Arbor Hill, but also Blackrock are two zones where lots of trips are really short because they stay within that specific zone. Again, this you can export, so you can use it in all kind of GIS tooling, which is quite useful. And just quickly, you can also do all kind of pretty cool analysis here. For example, this Sankey diagram showing the most important relations. So here you can really see between the four most important relations, how is the travel in between. So you can see that between Ballsbridge and Blackrock, actually it's a pretty heavy flow. In this case, 2,300 vehicles, which is relatively to the other flows quite significant. And here you can also do, for example, in this case, I selected the full day, morning rush hour and evening rush hour. So you can really also compare how does morning rush hour compare to evening rush hour and what have you. And there are also some other really cool analysis, like for example here, visualizing it on the map. What are the most important flows? Yeah, here we go. So here we can see the most important relations, actually only for the 5 highest, well, sorry, for the 95% most trips. And you can really click and see between the different zones, how many trips are we talking about. So this is one example on origin destination. The other example I wanted to show is totally different. So as I mentioned, this is not for if you're interested, where does the trip start, where does it end? Actually, this example is in Belgium, not in Ireland, but I thought it's a quite cool example. This is in the area of Brussels, and there is an intersection with traffic signals, which is causing lots of congestion during rush hour. So if you do a simple analysis, then you see, okay, most important relations here are north-south and east-west. Okay, that makes sense. It's a big intersection, two major provincial roads that cross there. But this was not the reason for this analysis. It was actually an analysis that was requested because a lot of people are taking an illegal route to avoid the congestion on the traffic signal. And they wanted to know how big is this real problem. And you can actually do that quite easily by using the same tool. Let me show you. Needs to load a little bit. Here we go. Because we're not only looking where does the trip enter the area, where does it leave, you can also say where did it travel via. So in this case, I'm selecting this specific point on the north side as the origin. This location going to the Brussels Ring Road as the destination. Okay, so we talk about 884 trips. Okay, interesting. But the real beauty comes here. So you're asking how many cars drive via the congested intersection and how many people take this small residential road to drive from A to B. So when you say, well, let me select that as a via point, then you see something funny. So over the full day, 60% of traffic takes the major intersection and 40% takes the small street. But in this case, I'm selecting all day. If I say just morning rush hour, then you see that actually the majority of traffic, 53%, is actually taking the small residential street rather than the major intersection. This is a typical use case for urban planners to understand how do people use the road network. Where are my problematic points? What's the kind of impact of that? But also, what can I do and can I measure what's the impact after I change something? So in this case, there's more information than what I show you here. So for example, for my morning rush hour, you can see that mainly between 7 and 8 and 8 and 9, this is a problem. Rest of the day, not really. So this can be really valuable inputs for defining how you want to resolve this specific problem. You're not only getting what's the hour of the day of this specific trip, you also get information about what's the trip length. So in this case, it's majority is relatively short trips. And also the duration. So the majority of trips that make this specific route have a drive time of about 30-35 minutes. It can all help you to understand what kind of traffic am I dealing with. Is this local residential traffic? Is it regional traffic? And so on. So that's my demo. Back to you, Mac, to discuss the rest of the webinar.
Perfect. That's great. Yeah, thanks so much, Sharon. I would just say, yeah, to any ArcGIS users, the TomTom Move portal is great to use. It's very intuitive, syncs really well. You know, if you have an area of interest, you can upload a shapefile right to the Move portal, you know, for maybe the area that you do want to assess the traffic for. And then, like Sharon mentioned, you can bring that data back in, you know, as a shapefile or GeoJSON. You know, into ArcGIS Pro, publish those up as web layers, and you get all that attribute information. So great, very seamless to work between the two. Cool. So I think from here, I'm going to hand things over to Chris. So 1 second here, Chris, and should be good to present.
Yep, I think so. Cool. Can you see my screen now? Can you see the screen?
So I'm actually not seeing it, but Sharon, yeah, you're able to. Yeah, perfect. Yep, seeing it on my end as well. Thank you.
Yeah, I can see it, Chris. Yeah.
Perfect.
All good.
Cool. So, my name's Chris. I'm head of customer success here at TravelTime. Yeah, thank you so much, Meg, for inviting us along, and yeah, thanks, Jerome. That was a super interesting overview of the TomTom data. So yeah, who are we at TravelTime? So we are essentially an API that lets you search the world by travel time instead of by distance. And there's a kind of whole range of use cases and ways in which this can be used. But it kind of breaks it down into sort of 3 core pieces of sort of spatial analysis functionality. So this is the ability to create isochrones or trade areas or reachable areas. So show me how far I can get from an origin based on a certain travel time. Origin destination matrices, so kind of similar to some of the stuff that Drone showed. But yeah, lots of origins, lots of destinations, and calculating the journey times between them. And then also A to B routing, so taking origins and destinations and generating the sort of turn-by-turn directions and door-to-door routes between those locations. And I guess the key thing for us, and kind of what I'm going to focus on today, is the ability to do all of this functionality for any means of transport. So not just for driving, but also for walking, for cycling, and most importantly, for public transport. And even within public transport, being able to break it down into subsets of that. So just buses or just trains, and even some multimodal versions that combine things like driving and train. So looking at journeys where you can drive to a train station and then carry on by train, which is a typical sort of commute type from a commuter belt into a large city. And yeah, we've had this API live since 2014. It's now available in 40 countries around the world. So yeah, essentially all of Europe, North America, and then yeah, a few others like in the Middle East, Japan, New Zealand, Australia, South Africa, and yeah, kind of expanding that global coverage the whole time. We process a huge amount of data through the API. So last year alone, we did about over 200 billion different locations went through the tools. And what we're trying to do as a business is not to build our own end-to-end kind of GIS platforms. So we're not trying to build a sort of travel time tool that gets used as its own GIS. What we're trying to do is enable our data to be used in the tools that our clients are already using. And yeah, one of the most important ones we have is an integration into ArcGIS Pro. So a plugin that lets you use the travel time API and all of this functionality directly from within Pro. And the benefits of this are kind of obvious, but it means it's completely code-free. So you don't need any kind of developer resource or anything to start using the travel time tools. And also it means that you can sort of use it in conjunction with all of the other amazing functionality that Pro has. So the travel time analysis is always only one part of the analysis that someone wants to do, whether it be an office relocation or looking at where to open a new retail store or real estate analysis. TravelTime is kind of core part of that, but having it in Pro means that you can then layer over the top of that all of your other data sets and use all of the other functionality to kind of completely answer the business question that you're looking at. So yeah, the focus today, I'm going to show you kind of what this looks like in Pro and just show you some of the functionality that we have there. And just quickly to touch on kind of who is already using this. Yeah, we have as I said, the technology can be used in so many different ways. But looking at the sort of analytics view, obviously real estate is massive because yeah, everything is about locations and looking at locations in relation to other locations in terms of catchment areas and travel time matrices, this kind of thing. Financial services, so being able to look at potential investment opportunities based on travel time and that kind of thing. We've got sort of growing demand in the public sector, so looking at where to open healthcare facilities or hospitals or testing centres or vaccination centres. We're currently now powering the NHS test and trace, so allocating people to their nearest testing centre based on travel time rather than straight line distance. And then things like retail, so where to open new stores or where to consolidate and close stores to give you your best kind of catchment area of current or potential customers. And then things more generally around transport planning and consultancy, so looking at future transport network initiatives and areas where there's kind of lack of transport coverage and that kind of thing. So it's a kind of huge spectrum of different use cases, but the underlying technology is the same for all of these. And I'm now just going to jump into ArcGIS Pro and show you some of this functionality in action. So the first thing I'm going to show you is the Isochrones, so creating catchment areas. And again, just stressing that this can be done for any means of transport. So we have this add-in into Pro. It's kind of super easy to install. It's just one thing that puts all these tools in one go. It all works through the API, so there's no sort of hosting of GTFS data or configuration or anything like that. All I've done to get to this point is install the add-in and put my API key details in, and that's good to go. So we have this kind of set of tools up the top here. And the first one we're going to look at is this quick time map. So this is just the easiest way to get up and running, creating isochrones without even having to add any layers of points or anything into Pro. So we can choose our means of transport. As I said, we're going to look at public transport mainly today. We can choose some time bands. So I'm going to do a 30-minute, a 60-minute, and a 90-minute isochrone. We can choose our time zone, whether we want to do a leaving search, so I want to set off from this point, show me where I can get to, or an arrival, which is I want to arrive at this location at a certain time, where could I set off from and complete that journey. And there's a few ways we can run this. The easiest is just to put an address in here and hit run. And what this will do is it will geocode that address, turn it into lat long coordinates, and use those lat longs to create our reachable areas. So we get these 3 new layers added into Pro. So we get our sort of 90-minute, 60-minute, and 30-minute catchment areas. I guess the most obvious thing to see initially is how important it is to be able to do this kind of analysis for public transport. So the shape of the isochrone when doing public transport compared to what it might be like for driving is very, very different. So we get these kind of islands where maybe there's a train station there, so you can get off the train and you can continue your journey walking around that train station, but you can't actually reach in between those train stations because the train doesn't stop. So this gives us a really kind of rich and accurate picture of the catchment area of this particular site. going to remove these. And say we wanted to create catchment areas around lots of different sites at once. So if I had a layer of points, and this is just sort of the 10 largest towns and cities across the island of Ireland, if we wanted to do a public transport catchment area around each of these sites, so potentially kind of looking at comparing these for suitability of opening up a new retail store or something like that. We could go and do them one at a time using the tool I just showed you. But in our catalog pane, we have another TravelTime platform toolbox where we can run these tools off of layers of points. So we're going to use our time map tool. And again, the configuration is all fairly straightforward. So we are not a kind of specialist GIS company. We've tried to build these integrations in a way that can be used by non-GIS specialists and sort of more general business users. So there's no kind of complex terminology or configuring networks or anything like that. It's all very straightforward. So we simply pick the layer we want to run this off, since our island cities. We can pick an ID from this to kind of identify the isochrones in the output. We choose our time zone, so we can use UTC. Again, this idea of departing or arriving. So we want to do an arrival search to see, for these potential retail stores, who could access these stores from a given area for public transport. We set an arrival time. Let's say we're interested in journeys that get there at midday. And we now get our full range of transport types that we support. So as I mentioned earlier, even within public transport, we can narrow it down further and say, okay, let's just look at the catchment areas for bus journeys or for train journeys, for example. For now, we'll look at the whole public transport model, which combines all of those. We can set our travel time. So we actually support up to 4 hours out of the box. So if you want to look at really large travel time catchment areas for sort of logistics planning and that kind of thing, you can do 4 hours. In this case, we'll do, say, 90 minutes. And we can choose how we want these shapes to be displayed. So normal is going to create a separate isochrone or separate catchment area around each of these sites. We can get it to calculate the intersection. So if we were looking at kind of a whole portfolio of retail stores, for example, we wanted to see where is reachable from all of those, we could run an intersection. And we can also run a union, which will blend all of those isochrones into one to give us an idea of kind of the total coverage that we have. Say if we were looking at kind of public services and we wanted to see how much of the area is covered by any service, we could create a union. But now we'll just go with normal. And in all of our tools, we have some sort of advanced parameters that we can configure if we really want to play around with the specifics of the analysis. So things like walking time, for example. So when doing this public transport catchment area, we can set how long do we want to allow someone to walk from their origin to the first public transport stop, and then again from the final stop to their destination. So we'll leave these as the kind of defaults for now, but it allows you to kind of really tinker and tailor what the parameters you're using to get exactly what analysis you need. And then we simply run this. And one of the other kind of, I guess, benefits of the TravelTime tools is the API was actually originally built to be what we call a search-facing application, so to be on consumer-facing websites, and therefore it's been built to be very, very performant and very fast. So here we've just done 10 90-minute catchment areas, but you could put in layers of hundreds of or thousands of points and generate loads and loads of isochrones if you wanted to analyze, every possible potential location for a real estate investment or a retail store or anything like that. And I guess the next kind of logical step would be, adding in more data and using these isochrones to filter that. So looking at population catchments or access to where your customers are or your suppliers or patients or users and that kind of thing. So that's kind of isochrones. The next piece of functionality I wanted to show you is doing origin destination matrices. So in this example, we're going to take a layer of a load of different employee addresses across Ireland. And we want to look at the travel times between all of these and a number of potential office locations we're looking at in Dublin to see which kind of has the lowest potentially average commute time. So we have a tool again in this travel time toolbox called time filter. And again, it has very similar configuration, just a few fields to fill out to run this analysis. So we want to calculate journeys that set off from these employee addresses. Again, we can pick an ID. Same idea around time zones. We want to calculate journeys that arrive at these offices at 9 in the morning. So that's sort of typical commute analysis. Again, we can do this for any method of transport, or we will do public transport. And we can set a maximum travel time here if we want to. So we could say we only want to actually see commutes that are within 90 minutes, for example. But for here, I want to see as many of these as possible. So I'll put 4-hour limit in. So this will calculate any of these commutes that are within 4 hours by public transport. And we want to arrive at our Dublin offices. And again, we just pick an ID. And here we have the same advanced fields that you can configure around walking times and that kind of thing. But I will just keep those as the standard for now. And this is kind of probably where the travel tables are most powerful. So yeah, generating isochrones is great for kind of filtering other data sets and getting a sort of visual idea of catchment areas. But this tool lets you actually generate thousands and thousands of travel times incredibly quickly. So yeah, it's already completed these, and we get a sort of visual of reachable and unreachable, but the real value is in the attribute table itself, where we get a huge amount of data, and each of these rows is essentially one departure location, so our employee ID, to one arrival location, so one of these Dublin offices. And then it tells us, is it reachable by public transport, given the parameters we set? And if it is, what is the travel time? And this is in seconds. So we can really quickly get a huge amount of incredibly valuable data on all of these travel times between all of the different employee addresses and offices to make a decision around which of these sites would give us the lowest commute time for public transport. And this could also be used for allocating patients to their nearest hospital facilities, or allocating customers to logistics depots, so which depot should serve which customer, and all sorts of other potential use cases. And then the final piece of functionality is our A to B routing. So say we've decided on an office and we want to check what the commutes will look like for a number of kind of key employees. So here we've got our employees and we've got this office, and we want to do the public transport journeys for all of these employees to this office. So again, we go into our same travel time toolbox, and this time we use the routes tool. And again, very similar configuration. So we set off from our key employee addresses with an ID, same time zone, and we want routes that arrive again from 9 AM by public transport to this head office location. And we can choose how we want these routes to be displayed. I'm going to do it by transport type, which will show exactly what types of public transport are being used for each of these different legs of the journey. And again, we've got our same advanced parameters. So I'll just make walking time 15 minutes. And then we run this tool. So this is probably used the least of our three kind of core functionality, but it's often a really nice way to validate the results that are shown by the other tools, because it gives you the sort of visual of what transport types are being used in the analysis. And also, yeah, it's a great way to kind of visualize the routes. And also in the attribute table of this output, we can get the full turn-by-turn directions for what each of these routes actually involves. So we can see exactly what services are involved, what time they leave, what time they arrive. And we can use this to kind of, particularly in the sort of transport modeling and transport planning sense, seeing which services are potentially going to be overutilized or underutilized, areas where there are unreachable locations that need potentially new infrastructure, and yeah, lots of other potential use cases. So yeah, that's a kind of very brief overview of the tools we have in Pro. As I said, the sort of breadth of use cases is wider than we can kind of even get our heads around sometimes. But yeah, real estate, retail, public sector, financial services are definitely the biggest ones we see currently. And I will hand back to Mick.
Awesome, thanks, Chris. Yeah, I think also really great just that TravelTime does, the APIs right in Pro, so really easy to use. And then in terms of, sharing that, publishing that up as a web letter, if you are using ArcGIS Online or sharing within your org. So again, really easy and joins very well. So I will pop back my screen on here for just a second then. All right, so did have a couple questions come in, so I think if you guys have a bit of time, I will try and get through as many of these as we can. I think, Jaren, one of the first questions is for you. That question is, can we change the name of the fields, e.g. harmonic average, to something else for general understanding?
No, you can't. That's kind of the standard, but of course there is a lot of documentation explaining what it exactly is. And of course, if you download the files, shapefile, GeoJSON, or just the Excel, you can change everything, of course. So don't worry. We rather deliver too many statistics which you ignore, then we face the problem that you say, it's great, but I just missed that and that value. So that's kind of our approach there.
Perfect. Cool, Jaren, I've got one more for you as well, and that is, does the TomTom OD analysis have breakdown by vehicle classification?
So the answer is no, we do not have that, and that's mainly because we simply most of the time don't know from where a vehicle comes. So let's say you're using a smartphone app, we don't know if you're stepping into a light truck, a heavy truck, or a passenger vehicle. So we just put everything together, and what I can say is, mainly in Europe, the majority of our data comes from passenger vehicles. So it is biased in that direction.
Cool, that makes sense, cool. Cool, next one, I can take this one. Question on associated costs with accessing the data. Yes, there are, and I do have my email up on the screen, and if you are interested, feel free to reach out to myself or your Esri Ireland account manager. They'll be happy to have a chat through, and Chris and Jaren, as you can see, have been very helpful in this webinar, so they're also very helpful to answer more specific kind of questions about their data sets or share more on that. So that's the answer for that one there. Cool. Chris, have one for you, and that is the TravelTime functionality available on a credit basis within ArcGIS Pro as some of the other ready-to-use tools are?
Yeah, so in general, we don't use a sort of credit model. We have a kind of subscription model where it's based on a per user seat. So you purchase a license for the year for a single user in Pro, and it essentially gives you sort of unlimited use. So you can do as much analysis you like, using all of the tools, all the data you have, for a kind of fixed fee. So we don't charge for how much you use it, because we want people to be able to use it as much as possible and have kind of full flexibility to run scenario models or run something and then think, oh, actually, I wish I'd kind of set them up slightly differently, or actually, I'd like to look at it for a different time of day or with slightly different parameters. So it just gives you sort of full flexibility to do as much as you like and not have to worry about how much it's going to cost you.
Awesome. Yeah, big plus. Big plus there. Cool, Chris. One more for you. Actually, this one has come in twice, and it's a question on data sources for the data that you guys have.
Yeah, so I guess it's kind of different for the different modes of transport. So for public transport, we basically gather public transport agency data. So we kind of hoover up all of the data from all of the public transport agencies in a given country and kind of clean them and consolidate them into one overall model. And this is, a huge part of what we do. So in the UK, I think we have over 1,000 different public transport agencies data in the model. So it's not just kind of one or two, it's every single local provider and national provider. And we update all of that data at least every 2 weeks. So you're always getting the kind of completely up-to-date view of what the public transport networks and timetables are looking like. On the driving side, we build our own driving models kind of from the ground up. So we're not pulling in sort of live traffic data from someone like TomTom. We are building those models ourselves from the ground up based on all sorts of open data sets and building speed profiles onto the maps that then get used as the driving model.
Awesome, great stuff. And Chris, one more for you, actually, same one that we had for Jen, but for Chris for you as well. Are vehicle classifications available in the TravelTime platform?
So we only support one driving model, which is kind of a car driving model. We don't have a specific sort of HGV model, just the driving one for cars.
Cool. Cool. Sharon, have one for you. And that is, what percentage of journeys does TomTom have details or coverage for?
Yeah, that's of course a really difficult question, because what's the truth? No one knows how many journeys you actually have. And the only thing I can say is that we did do quite some comparisons, comparing the number of vehicles we have in our database with what these loop detectors measure. And the same as we do that by comparing it to what is statistically possible to drive over specific roads. On average, we say, well, between 5 and 20% is roughly what we get in our database. And some of our users are actually actively comparing TomTom with loop detectors that are available in a city. And based on that, they kind of scale things up to the whole country. Well, using Esri tooling, I think that's a great tool to actually do that exercise. But to answer, it's flexible. On highways, we tend to have a little bit higher percentage than on some rural roads far away from the city, where there's less traffic, but also maybe less people using sat-nav devices or smartphone apps in their car. So it fluctuates.
Cool, that makes sense. Cool, I think I've got about a couple more here. I think I can take this one as a question of not understanding if TravelTime also uses TomTom data. And guys, correct me if I'm wrong, but I don't think either of you use each other's data, kind of all traffic data, but in slightly different ways and sources. But again, correct me if I might be missing something there.
We need to talk.
Yeah, not yet.
There we go. Watch this space. Cool. And then I think looks like the last one here is, and I can take this one as well. So kind of a follow-up to the cost. There was a question on, is any data made available as free or open data? I think I'm going to answer for you guys and say I don't believe so, but that in mind, if anyone is interested in kind of getting started, do have trial options. I believe both of you have some free trial options, and Esri, we have that option as well, so can definitely trial Esri and TravelTime and TomTom data and kind of play around and see what that looks like. A limited version, of course, for the trial across all boards, but definitely an option there. All right, so I think that is about it on questions that I am seeing. If I've missed any, I will definitely follow up on those, but it looks like we're just about at the hour anyway. So thanks again to everyone who's able to join. Oh, one question, I'm not sure if I might have covered this. The session was recorded, so if you weren't able to join or make the entire time, we will be sending a follow-up email that does have the recording for information. So many thanks again to Chris and Jaron for taking time, guys, to help out today. And thanks to everyone for attending. Bye.
Bye, guys.
Thank you. Bye, guys.